This section is about exponent simplification rules. The rules for exponents can be often discovered through examination of simple cases. Let's discover what the rule is for any base to the power of 0. We'll look at a pattern. 2 to the 3, 2 to the 2, 2 to the 1, and 2 to the 0. So 2 to the 3 is 2 times itself times itself times itself. That makes 8. 2 to the 2 would be just 2 times itself, making 4. 2 to the 1 would be itself. So the question is, what number comes next in the pattern? Well, as you can see, each time you go down an exponent, you're dividing by 2 every time. So if we continue the pattern, what comes next? 1. Would this pattern hold for a different base, such as 3 to the power of 3, 3 to the 2, 3 to the 1, and 3 to the 0? Three to the 3 is 27. 3 squared is 9. 3 to the 1 is itself. Each time we're dividing by 3. So if we continue that pattern, what comes next? A 1. The fact is that this pattern will hold for any base. So we're going to let that base be represented by a variable a. And the rule is anything to the 0 is 1. What happens when you have a base to a power multiplied by that same base to another power? To figure out what the rule is, we could come up with a simple hypothetical example such as 2 to the 3 times 2 to the 4. Now what I'll do is I'll write out the meaning of 2 to the 3. 3 2's being multiplied. And then let's write out the meaning of 2 to the 4, which is 4 2's being multiplied. I want to come up with a new exponent where the result here on the right would be equivalent to the original. What exponent would work? Well, if you count up all the 2's, you'll see that there are 7 of them. Now, how do you take the numbers 3 and 4 and make 7? Well, intuition should tell you that you could add them, and that is the general rule. 2 to the m times 2 to the n is 2 to the m plus n. Would this process hold for any base? Let's try a to the 2 times a to the 3. How many a's do we have? 5. And 2 plus 3 makes 5. So a to the m times a to the n will equal a to the m plus n. Notice that the bases do have to be the same for this rule to hold. We want to find a general rule for dividing 2 to the m by 2 to the n. Let's start with a simple specific case, such as 2 to the 5 over 2 to the 3. I'll write it out. And now we can use the technique of canceling when we have identical numbers above and below. They can actually cancel. And 3 of the pairs cancel. How many 2s are we left with? 2. Now how do you take the numbers 5 and 3 and make 2? Well, you could subtract them, and that's the rule. 2 to the m over 2 to the n is equal to 2 to the m minus n. Would it work for any base? Let's try a to the 6 over a to the 2. Two of the pairs cancel, leaving us with a to the 4. And it appears that once again the rule holds. A to the m over a to the n will be a to the m minus n.